rational and irrational numbers. We can represent rational numbers in the decimal form. Irrational numbers can also be represented in the decimal form. The decimal representation of numbers is known as decimal expansion. Let's learn more about the decimal expansion of real numbers. We will also learn how the decimal expansion of a number helps us to identify whether the number is rational or irrational. Let's observe the decimal expansion of some rational numbers to begin with and try to find a pattern in them. We'll first see the decimal expansion of 17 divided by 8. On dividing 17 by 8, we get 2.125, which is therefore the decimal expansion of 17 over 8. Observe that dividing 17 by 8 gives the remainder 0, and then the division process comes to an end. This type of decimal expansion obtained is known as terminating. Let us now divide 50 by 12 and observe its decimal expansion. Observe that when we divide 50 by 12, the remainder 8 starts repeating itself. Consequently, the digit 6 repeats itself in the quotient, and this repetition continues endlessly. When the division process does not terminate because a number keeps recurring in the remainder, and consequently a digit or even a block of digits recurs in the quotient indefinitely, the decimal expansion obtained is said to be non-terminating recurring. We represent non-terminating recurring decimal expansion by placing a bar over the digit that recurs indefinitely. In this example, the digit 6 repeats itself indefinitely, and so we place a bar over 6. Now look carefully at this division of 1 by 37. What do you observe? Observe that while dividing 1 by 37, we get the remainder 1, which is the same as the original dividend. If we proceed with division, then the same block of remainders, 1 and 26, will recur. Hence, we will never get 0 as the remainder. In other words, the division process will not terminate, as the block of remainders repeats indefinitely. As a result, the block of digits in the quotient repeats itself too. Since the decimal expansion doesn't terminate, and also a block of digits recurs indefinitely, this decimal expansion is non-terminating recurring. We can write the decimal expansion by using a bar over the repeating block of digits. Hence, you've seen that the decimal expansion of a rational number is either terminating or non-terminating recurring. We've seen how to identify the decimal expansion of a rational number as terminating or non-terminating recurring by dividing the numerator by the denominator. We can also identify the type of decimal expansion for a rational number without actual division. Let's take 4 examples of rational numbers to understand this method. First, we write each rational number in its lowest form. Next, let's write the prime factors of the denominator of each rational number. Now, if the denominator of a rational number in its lowest form has the prime factors 2 or 5, then the rational number can be expressed as a terminating decimal expansion. If the denominator of a rational number in its lowest form has any prime factor other than 2 or 5, then the rational number can be expressed as a non-terminating recurring decimal expansion. Let's check our classification by using the method of long division. In the first example, we divide the numerator by the denominator. As you can see, the remainder is 0, and therefore this rational number can be represented as a terminating decimal expansion, which is what we expected. Similarly, let's divide 25 by 12 to check our classification. Notice that the digit 3 in the quotient repeats itself indefinitely. Therefore, this rational number can of course be represented as a non-terminating recurring decimal expansion. Thus, we can identify whether the decimal expansion of a rational number is terminating or non-terminating recurring also, by simply observing the prime factors of the denominator. We've seen that the decimal expansion of rational numbers can be either terminating or non-terminating recurring. What can you say about the type of decimal expansion of irrational numbers? Look closely at the decimal expansion of some irrational numbers. What do you observe about the decimal expansions? How do they differ from the decimal expansions of rational numbers? The decimal expansion of irrational numbers do not terminate after a finite number of digits, and so these are non-terminating decimal expansions. Furthermore, observe that no single digit or a block of digits repeats itself indefinitely in these examples, and hence these decimal expansions are non-terminating, non-recurring. In fact, the decimal expansion of any irrational number is always non-terminating, non-recurring. Thus, based on the type of decimal expansion of a real number, we can identify whether the number is a rational or an irrational number.